Okay, so this is the quiz we had last week, and a lot of kids asked me about how to think about it or explain it, and so I'm here to do that now. So basically, this is all about an equation, C equals 2.59 G. It shows how much it costs to buy gas at a gas station on a certain day. Okay, this is the key here. That's the deal. So now it tells us, and this will happen a lot, in the equation, C represents the cost in dollars. That's right there. And G represents how many gallons of gas were purchased. Right there is the G. Okay, and so you should know that this means C equals 2.95 times G. Right? Multiplication is implied there when you see a number next to a variable. It's like the multiplier. Okay, and so here it says write down at least 4 gallons of gas, cost, ordered pairs. Okay, well, ordered pairs, you should know that you learned that in 4th grade. And ordered pairs, which would graph on a coordinate plane. They're always written in X, Y. Right? Okay, and so it tells you what order to put it in right here. Gallons of gas, cost. So the X value is going to be the gallons, and the Y value is going to be the cost. Well, how are you supposed to know what to write? Well, a lot of times when you're dealing with equations, you got to come up with your own information. You have to decide for yourself what to use. So I might use numbers like 1, 2, 3, and 4, which means you buy 1 gallon of gas, you could buy 2 gallons of gas, you could buy 3 gallons of gas, or you could buy 4 gallons of gas. And how do you figure out how much it costs each time? Well, that goes back to the equation, C equals 2.95 G. When you plug in the X value of the gallon number, G is gallons. So if I plug in 1 for G, 2.95 times 1 is 2.95, which means that's the cost for 1 gallon, $2.95, $2.95. And if I plug in 2 for gallons, 2.95 times 2, that's going to be $6 less 10 cents. That's going to be $5.90. I got that from knowing that 2 times 2.95 is $5.90. And then I do the same thing for 3 and 4. I plug in, if I bought 3 gallons of gas, G is 2.95 times 3. So that's like $9 less 15 cents. So $8.85. And then finally, 4 gallons is twice as much as 2 gallons. So I know it's $11.80 for 4 gallons. So those are my 4 ordered pairs. Notice I'm talking about X and Y for ordered pairs, right? But see, the equation doesn't show X and Y in here. It shows C and G, which gets confusing, I recognize. So I tried to relate it here because it says gallons of gas, cost. That's the same thing here. So it's all related. The G and the C are the same as gallons and cost. Okay, so before I move on with that, let's answer the part C real fast. It says, what does the 2.95 represent? That means in the context. Like, what is it literally talking about? And it's talking about, like I said before, it's the cost per, which makes it a ratio, per gallon of gas. That's what 2.95 represents in this situation. And now down here it says create a graph of the relationship. So I'm going to have to delete all this information so I can slide the screen up without losing it. So actually, I'll do this. Add a new slide. Okay, now it's gone, and now I can slide it up a little bit. So for graph, if you recall, there was an x-axis and a y-axis. This tall one is the y-axis, this is the x. And the x-axis represents how many gallons you buy, and the y-axis was the cost. And when you buy more gas, you spend more money. So 0, 0 is a point on this graph. But then when you bought 1 gallon of gas, it costs $2.95. Well, you have to kind of estimate here because these are whole numbers where you have the grid pattern. So $2.95 is right here on the y-axis. And when you buy 2 gallons of gas, it was $5.90, which is right here below the 6. 3 gallons of gas was $9 minus 15 cents, $8.85. So here's 8. So $8.85 would be right around there. And then finally, when you bought 4 gallons of gas, it was $11.80, which is right about here. So you should see that this makes a straight line, and it's going up pretty fast. And it would keep going. The more gas you buy, the more money you're going to spend, right? So that is the actual graph that should be on your paper. Okay, and then finally, part D says, Jada's mom remarks, which means says, you can get about 1/3 of a gallon of gas for $1. Is she correct? Well, basically what she's doing is she's assuming that $2.95 is about $3. And then she's saying 1/3 of $3 is $1. Now, is that true? Yes. And when it says, how did she come up with that? I'll just explain this in a sentence. She estimated the cost of a gallon of gas and divided it up into 3 parts. Okay, so that's all slide 1, the first half of the quiz. The second half of the quiz, click through, is, let's see if I can do this. Nope. Okay, so this slide, it gives you some information. It tells you, and this is really important, there are 3 cups, which is equivalent to 48 tablespoons. That's a ratio, and that's shown in the graph. Well, where is that literally shown in the graph? It's shown right here, at this point. It says 3,48. Right, remember, this is the x-axis, this is the y-axis. Coordinate points are always written in XY fashion. So if you go over to 3, up to 48, right, over to 3, and then up 48, boom. That is literally showing 3 cups is equal to 48 tablespoons. Now it says plot and label at least 2 more points to represent the relationship. Well, that's hard to do out of the blue. So what I would do is maybe set up a little table on my paper to the side and organize my thoughts that way. And if 348 is is the ratio, then I can figure out, what if it's only 1 cup? How many tablespoons is 1 cup? And I know it's 16, because 3 divided by 1 is 3, and 48 divided by 16 is 3. And then I could also figure out 2 cups, because then I can double it. 2 cups would be 32 tablespoons. So these are points that I can put on my graph. So I can go over to 1 and up to 16, which is about here, and then 232 is about here. And again, if I plot that, I also recognize that 0, 0 works. So when you have no, whatever it is in your measuring, when you have 0 cups, you've also got 0 tablespoons. So this makes the whole thing proportional, and it will keep going, right? So then you ask, for which value y is 1 comma y on the line you just drew? Well, that's right here. This is 1. And it was 16, right? It's right here in my table also. So it's 1 comma 16. And then it says, what is the k for this relationship? Well, the k shows up, remember, in the table as the horizontal multiplier. And so it also shows up as the y value when x is 1. So the k is 16 in this case. For every 1 cup, there are 16 tablespoons. And so for the equation, you need to remember that y equals kx. That constant is what you multiply every x by. But it's asking you to use c and t. So you have 2. First of all, so the k is 16. So this is a true equation for this scenario. But it's asking you for c and t. Well, I know there's got to be t equals 16c, not the other way around. Because when you plug in like 1 for cups, 1 times 16 is 16, which matches the number of tablespoons. Okay, so that's the story. Morning glories. That's everything.